scored 2,300 in the UCAT. I scored 2,300 in the UCAT in the cycle that just went, and I got offers for both medicine and dentistry. Yeah, let's just quickly start with the QR section. And if you do have any questions during the actual meeting, feel free to pop in chat and I'll try to answer. So just a quick little overview of the workshop today. So it's the third MedReadyGo UCAT workshop. This one's QR specific. We did a introduction to the UCAT and then a VR specific one as well. We should hopefully do those again in the future if there's enough demand. We'll go through a quick overview of the actual quantitative reasoning section of the UCAT, what it's about, what it tests you on, then how the data is actually presented in questions to you for this section. Then I'll go through the calculator, a quick little tutorial on how to utilize the calculator for the QR section. Then obviously you have common skills that might be assessed in this section, time-saving tips, common mistakes, and also general tips, and then a Q&A feedback section where you can just ask questions if there's anything you're confused about or you need me to explain again. That being said, if you do have any questions during the actual workshop, feel free to ask it in the chat and I'll try to answer it. Okay. So the quick little overview. So quantitative reasoning is designed to test your ability to answer mathematical questions, and it's often when you're presented with text or data. You have 26 minutes to answer 36 questions, so approximately 43 seconds per question. So it's really just a really rapid fire round. Quantitative reasoning, the actual questions themselves are not that difficult. It's just the timing that catches people out. It does contain an on-screen calculator, and I would highly recommend using the number pad. So this is the calculator, and when I talk about number pad, I mean on your laptop, if you have one, it will be on the right-hand side where all the number lock and things are. On a computer, you might have to get a separate one, but it would be very useful to get one for your UCAT practice. It's a very time-pressured section, so it relies heavily on mental maths to save time. Don't rely on your calculator for every little calculation because it'll just waste time and you might not be able to answer all the questions if you do that. It tests you on a large variety of math skills, so it can virtually be anything, but it's mainly at GCSE level. It's not overly complicated. It requires you to have an understanding of maths though, but it's very basic. And yes, it is the easiest section to gain marks on. So to get a competitive score, it doesn't mean that you need to score highly in every single subsection. That's why people often spend lots of time trying to improve their quantitative reasoning and get 900, 800 plus on it, because it pulls your whole score up, just the quantitative reasoning section, even if you do average in the other sections. So that is something to keep in mind. And a little tip I have here is to use your whiteboard for this section, but it's more like a laminated notepad, and write down your formulae and any numbers that you have, because it's much easier to just write the numbers down instead of trying to remember them, because it'll just affect how fast you actually work throughout the section. Quick little tutorial of the calculator. So this is on the left is the UCAT calculator, and that's your number pad on the right. Make sure your number lock is on, otherwise these buttons won't work. So if it's not working, be sure to press the number lock button to see if it's on or off. Okay, so going through all the functions, you have the square root. It's not available on the number pad. I don't think I really ever used it in the UCAT, but yep, it's that button right there with the square root sign. Then you have the function key, so that's your addition, subtraction, multiplication, and division. Your division being the slash, multiplication being the star, the subtraction being subtraction, and the adding being the adding, and then your equals is the enter. Then you have your number keys. And then you have the percentage function as well, which I also think I didn't really use, and you probably wouldn't use it either if you're using multipliers, for example, or division. They essentially do the exact same thing. Then you have this function right here, which I think is really useful, changing the negative numbers to positive and positive to negative. So for example, if you have a small number and you if you have finding the difference between two numbers and you end up with a negative value, you can just change it to positive and continue using that same number. It just helps with saving time as well. For example, if you have already in your calculator, if you have 2,000 and then you want to find the difference from 10,000 or something, just an example, you would get minus 8,000, but then you have to use that minus 8,000 for another calculation. If you just press that button, it will make it a positive 8,000, and then you can use it without having to type it in again, which saves you a few seconds. And then lastly, you have the memory storage function. In my opinion, I never really used it, but I don't think Anna scored quite good without it. I think it's very complicated and it just requires more work. It's much easier to just write the numbers down. But essentially what it does is stores numbers using this, and it takes the numbers away and adds those numbers to any new values you input. You can find lots of tutorials on how to do that one online. Right. So the data is presented in quite a few forms in the actual quantitative reasoning section. So you've got pie charts, tables, which are one-way or two-way. We'll be going through the two-way tables today. The one-way tables are really simple, so I feel like it would be a waste of time to go through those. You also have bar charts, simple text, diagrams, so drawings of different shapes. And then you also have line graphs. So this is all things that you have seen before throughout your secondary school education or even primary school. So it's not much new stuff that you actually have to learn. And these are the common skills assessed, once again, stuff that you've already done throughout secondary school. So percentages, decimals, fractions, ratios, formulae. So you will have speed, distance formula, and I believe sometimes you might be given asked about the density, mass, and volume formula. Apart from that, you will be asked other questions, for example, to do with volume or area, but more often than not, they'll give you the actual formula underneath the question. Then you also have conversions, so converting between different currencies or different units of measure. Then you have the averages as well. So you have your mode, your mean, your median, and your range. Those are the 4 averages tested and that you've probably already done in the past. This is a new one though, so weighted mean, and I will be talking about that more later on. But essentially, you just have to times your value by this weight and do the mean exactly the same. So that's just the one new thing about the UCAT. Then you have area, volume, and then addition, subtraction, division, and multiplication. So really just really simple math skills. So it's nothing too complicated. All right, so let's just quickly, I think the best way to actually improve in the QR section is just doing loads of examples, because there's lots of amount of questions that they can actually ask you. So it's better to just apply the same principle. So I'm going to show you those principles that you can apply to different types of questions. And also, if you do know the answers, feel free to pop them in the chat and I'll tell you whether you've gone right. So pie chart questions, firstly, look like this. And the thing I want you to do here is to just ignore the pie chart straight away and read the question. This is just to save you time, and also because you might be given useless information. So the question says, among all the respondents, only 40% of those who said left thumb and 50% of those who said alternating thumb were self-taught typists. How many respondents were self-taught typists? So from the question, you can see it's talking about the left thumb and the alternating thumb. The right thumb and the both together are both useless pieces of information. Do you see why I said read the question first? Now, obviously, you'd have the calculator in the UCAT, but this is a really simple question. So 50% of those who said alternating thumb were self-taught typists. So 50% of 52, if you want to pop in the chat. It's 26. Yes, 26. All right. And then you do 40% of those who said left thumb. So 40% of those who said left thumb, which would be 0.4 times 65, and you would get 26 again. So 26 at 26 is 52, and just really simple math like that. So yeah, there's your correct response, and there's your explanation as well. So 0.4 times 65, 26, and 0.5 times 52 is 26, and you get 52 as your answer. So it's really just simple math, as you can see. Obviously, you can have some more complicated questions. And then moving on to the bottom one. So this is a different type of pie chart with percentages instead of numbers. So the graph shows the distribution of monthly expenses for people in a certain age group in a city. Then look over here. In a month, the combined expenses for a person in this age group in the city for rent and groceries is $5,270. How much more does the person on groceries spend on groceries per month than on rent? Now, there's a couple of ways you can do this question. You can see that you can add them together. So 32 is 62%. Then you can work out how much each percent is. So to do that, you do 5,270 and divide it by 62. You'll get 85, and then you can just times it by 2, which will get you 170. Right there, as it says there. A quicker method for this one, in my opinion, is because just by looking at it, you can tell that it's a 2% difference. Instead of doing 5270 divided by 62 and then times it by 2, if you just divide by 31, you'll get the same answer, and it'll just save you, like, even if it's just half a second, it all adds up in the end, and it can be used for harder questions. And that's basically pie charts done. It's very straightforward, very simple, the pie charts in the UCAT. You might have more really difficult ones, but those are really rare. Now moving on to two tables and averages. So the table shows the mean maximum and mean minimum temperatures, and you see every month for 5 months. Just read the headings of the table is what I would suggest. So you can see maximum, minimum, and then you can see months on the side, and then just jump straight into the questions. So the sum of the daily maximum temperatures of the first 29 days in April is 347.5 degrees Celsius. What is the maximum temperature on the 30th of April? Note there are 30 days in April. Now this is a question that comes up time and time again in the UCAT in different numbers, but it's always the same question, where it asks you about rearranging the formula for mean. So as you all know, the mean formula will be mean is equal to your values over the total number, and that would, as you can see, it gives you this value right here because we've been given the mean. So we're using the maximum temperatures for April. April has 30 days. So if you rearrange the formula to find out the total value, we'll have to do 30 times 12, which will give you an answer of 360. That's the total for the whole 30 days. We've already been given the first 29 days. So to find out the temperature on the last day, you would do 360 minus your 347.5, which would give you an answer of 12.5. Now moving on to the next question. If anyone does have any questions, feel free to pop in the chat, by the way. Okay, so next question. The maximum temperature in June is greater than 18 degrees Celsius. What is the median of the maximum temperature if the maximum temperature in June is also included? So now, once again, it's GCSE knowledge. You're using median. So median, to do median, you have to line them up from the smallest value to the largest value, cross off each on each side, and you would end up getting the middle value being your median. So now they've added a sixth value. So if you have that understanding of maths, you'll know that if you have a even number of, if there's an even number of values, when you're doing the median, you'll have to add the middle two values. So if you just add June at the bottom, just imagine it's there, the number doesn't matter as long as it's larger than 18. So if we were to cross off the values, so 0 is gone, June's gone, February's gone, we're left with 8 and 12 for March and April. And the next thing you'd have to do is your 8 plus your 12 equals your 20. And then you divide by 2 to get you 10 degrees Celsius. Now, the mistake some people do there is that they just start stressing too much because you've not been given a value. Quite a lot of the QR section, even though it's a very mathsy section, some of the questions don't require you to actually do maths. It's more about trying to problem solve, as you've done in this question. Then what is the range of the minimum temperatures? Once again, GCSE knowledge. So you've got the range is the difference between the smallest value, which is -10, and the largest value. So the -10 and the 5, which would give you an answer of 15 degrees Celsius. So that's just a really simple question. And then what is the mean of the minimum temperatures? So for that question, you would just have to add all your values together and divide by 5. Now, there's two common mistakes people make in this question. Firstly is that they ignore the minus and the positive signs. They would just look at the values. So they would do 10 at 8 at 4 and 5. That's the first mistake. What you're supposed to do is -10, -8, -4 gets you -22. Then add your 5 gets you -17. And then you divide by the second mistake. Just because this adds no value to the set of values you have, so the 0 degrees Celsius, does not mean you count it out your total of the values. So some people would do -22 and then divide it by 4. That's wrong. You'd have to do -22 divided by 5 to give you an answer of -3.4. and then divide by 5, and you would get a minus 3.4. So minus 10, minus 8, minus 4, plus your 5 gets you minus 17, and then divide by 5. Sorry, I think I made a mistake. Yeah, so minus 3.4. And this question right here, all in all, it should take you about 40 seconds, if I'm being completely honest. It's one of those questions where you can win time back, and there's lots of opportunities for that in the QR section. Now, the next part is tables and volumes. So you see how the UCAT incorporates various skills and assesses them within the actual within tables. So you've got tables with averages, tables now with these with volume. Now, read over it really quickly. It shows the specifications, some brands of cylindrical shaped garden rollers. You get your brand, your length of the roller, and the diameter of the roller. One thing to note right here is centimeters. Look at the units. Always check the units when you're doing these type of questions. And then you also see that they're giving you a formula, as I said before. And then move straight into the question. So, what area of a lawn would a fab roller roll in 20 complete revolutions? So what I want you to understand firstly about revolutions is if you were to have a wheel and there was a dot on the wheel, for the wheel to spin the whole way around and the dot to end up right at the starting position, that's 1 revolution. So for it to go 360 degrees, and that's something that's really important to remember. Now, the reason I said look straight at the question first and not the table was because it's only asking you about fab rollers. So everything else in this table is irrelevant. Just look at that one fab roller section and don't get overloaded with the information for now. And then looking at this section, what area of a lawn would it be able to complete? So for this question, you'd have to look at the curved surface area, which is why it gave you the formula for it, because that's what's going to be covering it. So that's one thing you need to remember, to look at the formulas that they give you, because most of the time they give it to you for a reason. And there's 2 ways to go about this. So firstly, you can use that. Some people might decide to change this diameter into a radius and then do 2 pi times 16 times the height. I think that's a waste of time. Just sub the 2 off for your diameter and just do 32 times your pi, then times your height. It just saves you time. Another thing to remember is if a question has given you a value for pi, don't use 3.14. Use the value that it has given you. Otherwise, you'll get the incorrect answer, and that will cost you marks, even if you do everything else right. So be really careful about that. If they don't give you a value for pi, then obviously you can use 3.14, but that rarely happens. So now we're doing the fab roller. So we do 2 times the pi. Oops. We'll do 2 times pi, then, sorry, not 2 times pi, 32 times pi, which is 22/7, then times by 57, which will give you an answer of 5732.6, and that is in centimeters squared. Remember when I told you to look at your, be wary of your units. Then obviously to get from centimeters squared to meters squared, or just a word of advice, to go from any centimeters cubed to millimeters cubed or meters cubed or squared, you just need to do as you do normally. So to go from centimeters to meters, you would just divide by 100. Because it's squared, you would divide by 100 squared. If it was cubed, you would divide by 100 cubed. Same with millimeters and centimeters, divide by 10 cubed, 10 squared. Just something to remember for the UCAT, because you will need to convert a lot. So if you were to divide by 100 squared, it would give you a value of 0.57, and then you have 20 complete revolutions. So then times by 20, because the value you just had was the area covered in 1 revolution. And if you times it by 20, you get an answer of 11.465, and then round that up to whatever significant figures, and you would get that the answer is 11.47 meters squared. Now moving on to the next question. An Agri-R roller was used to roll a garden of length 20.02 meters in 105 revolutions. Assuming that the roller made only complete revolutions, what is the width of the garden? So obviously it's going to remember a few formulas for this one. So length times your width. You've got the length, but you don't have the width. We're going to work out the area. So looking at the Agri-R, one thing I have to show you guys right here is that to make it easier for yourself, if you do get confused with converting between centimeters squared and meters squared, just convert before you even do your even do your calculations. So that 91 centimeters, if you just change it into 0.91 meters, and your diameter becomes 0.46 meters, and then you times by 22/7, and you times by 105, you get a value of 138. Now that's in meters squared, so you don't need to do your conversion now. It's just something that saves time, and it's also less confusing. And then if you were to divide by 20.02, because width times length is equal to area, rearrange that formula in your head, you would get area over length is equal to your width, and you would get an answer of 6.9, which is B. Now for the next question, if you lot want to have a try, and then I'll go through it, I'll give you about 40 seconds because that's how long you would get in the UCAT. So a garden rolling services company charges 69 pence per square meter to roll a garden. If the company used a garden R roller to roll a garden in 70 complete revolutions, how much did it charge the customer for its rolling services? Remember, £1 is equal to 100 pence. I'll give you all about 5 seconds if you want to have a go at this question before I give the answer out and walk through it. Please pop your answers in the chat. Is it A, B, C, D, or E? Do we think it's A, B, C, D, or E? Before I go through it. All right, so I'll go through it now. So charge 69p per square meter to roll a garden. If you used garden R roller to complete 70 revolutions, how much did it charge? So first what you have to do is look at garden R and work out the area that it covers in one revolution. So once again, you do your 0.5 times your 0.42 times your 22/7, and then times that by 70 because that's the number of revolutions. You would get an answer of 46.2. Now, don't be confused here. Don't use 46.2 because you still need to charge times it by your 0.69 to get your overall value, and that would give you an answer of 31.878, which means which rounded up will give you C as your answer. Now, what is the average radius of the 5 garden rollers? So there's 2 ways to do this one. Obviously, you can do the usual way, which is divide everything by 2, 21 plus 23 plus 20 plus 16 plus 23, and then divide by 3, and you get an answer of 20.6. Or you could do the other method, which I prefer, which is just do 42 plus 46 plus 40 plus 32 plus 46. Gives you an answer of 206. And then instead of dividing by, instead you can just divide by 10, and you would get your answer of 20.6. Because you divide by 2 and then you divide by 5. I just feel like it's simpler to do it that way. It just like looking at it is simpler, and it just saves you that extra bit of stress. All right, next question. Now we're moving on to bar charts. Really simple in the UCAT, to be fair. The bar charts questions, they're not really that hard. As you can see right here. Let's just really quickly look at it. Turtles released, number of turtles released, and the years done. That's all we look at. Then look straight at the questions. So the number of turtles released in year 1 was a 60% decrease from the number released in the year before year 1, and we don't have no data there for that, so we'll just call it year 0. What was the percentage decrease from the number released in the year before year 1, so year 0, compared to the number released in year 2, which is right here, 60? Now, there's the normal method where you can do it, which is the change divided by the original value. So, so first you see that it was a 60% decrease. If you know anything about multipliers, you'd know that a 60% decrease is equal to 0.4 as a decimal. Let me just pull out and really quick. So if you see that 50 is equal to 0.4, I'm only showing you this part because you're going to need it along the UCAT with division multiplication. and stuff like that. And so what most people do is they'll times it by 10 to get it to 4 and then divide it by 4. Simply just divide this side by 0.4 and this side by 0.4 and you'll get your value, because so that this side will equal to 1, and 1 obviously, as you know, as a multiplier is equal to 100%. And then if you do your 50 divided by 0.4 as well, you get that that's an answer of 125. So that's how you can easily get your what the actual original value was from the decrease or the increase using multipliers. And that's something that's really comes in handy for saving time, because there's lots of questions about multipliers or percentage changes in the UCAT. Just divide by 0.4, because obviously 0.5 times 1 is 0.4, and you get an answer of 125. Now don't leave it here. It's going to say what was the percentage increase from the number released in the year before, year 1, so the 125, to the number released in year 2. So you're comparing the 60 to the 125. What was the percentage decrease? There's the usual method, which is find the difference, 125, take away 60, and then divide it by 125. You'll get a value of 0.52, which is 52%, which is obviously B. The method that I like to use is that I do the new value, which is 60, divided by the 125, and it'll give you an answer of 0.48. Now, just looking at that value, you can tell if you can do the maths quick enough in your head, it would the corresponding value to get to 1 would be 0.52. I just find it quicker than obviously typing out and doing those different calculations, because that's just one calculation you can do into your calculator instead of doing 2 to 3 separate ones. It also works for percentage increases. You just need to remove the 1 off the front, and that's your new value. Then that's for percentage increase and decrease. Just remember that. That's just a tip to save time. Then what percentage of the total number of turtles released over the 4 years was released in year 4 alone? So look at year 4, and you have a value of 90. Then you have the total. So do 90 out of the total. So 90 or 50 or 50 or 60, or you can just take the 0 off, and you could do 9 plus 5 plus 6 plus 5, and that'll just get you a value of 25. And yeah, it's 25, and then 90 divided by your 20, your 9 divided by your 25, and you'd get a value of 36%. So you can also simplify numbers as long as you're taking off the same number of zeros from each number that you're using in your calculation. How many more turtles were released in years 3 and 4 combined than in 1 and 2 combined? See, if you take it, you can do 140, 110, there's a 30 difference, or you can do 14 and 11, and there's the 3, and then you remember to add your 0 on, so it's 30, which would be A. And then how many turtles were released in year 5? Well, we have no information about 5, but now we can look over here at the top. You see why I said look straight to the questions, because we didn't even need that information to part D. So the graph shows the number of sea turtles released back in the ocean by a rescue center over 4 years after successful rehabilitation. The percentage increase in the number of turtles released the 5th year, year 5, from year 4 is the same as the percentage increase from year 1 to year 2. Using the method that I showed you, 60 divided by 50, you'd get 1.2. So you know it's a 20% increase. And from year 4 to year 5 is the same increase. So you times by 90, and you'd get a value of 108. If you were to go about the other method, you do 60, take away 50 over 50, and you'd get an answer of 0.2. Then you would have to do 0.2 times 90 is equal to 18. Then 18 plus the 90 equals 108. The method that I just showed you, 60 divided by 50, in your calculator, you'd get a value of 1.2. Then you could just do 1.2 times by the 90, and you can just do it all as one calculation. It's more smooth. And yep, you get an answer of 108. Now, moving on to the text. I want somebody to try that top question before I go through it. It looks like it's because the numbers are big and everything that it's quite difficult, but it's not. It's a really simple question. And that's the trick of the UCAT, that they use big numbers to try to throw you off. So if anyone wants to try that, I'll give you about 2 minutes. And one thing to remember with the actual UCAT, guys, the quantitative reasoning section is that you will be given really large values for some questions, like you'll be given 156 million, billions. Don't put the numbers in your calculator, even if they're given to you like that. That's why I said simplify your numbers, remove zeros. It just makes the whole process a lot simpler. Is anyone attempting this top question right here? Anyone? You're attempting it? All right. I'll give you another minute. All right, I'll go through the question now. Actually, no, give me your guess first, actually. Akshar, do you think it's A, B, C, D, or E? You're not sure? It's all right. It's all right. I'll just quickly go through it and then you'll see it's actually a really simple question. Hopefully by the end of this session, they should also look like an easy question to you. All right, going through it, read. The one thing I'd say about text questions is this is the only time when I'd suggest reading the actual question first. I mean, reading the text first, because obviously the information's in the text. So a water tank with external and internal dimensions shown is filled with water to a height of 1.75 meters from the base of the tank. External dimensions are there, internal dimensions are there. Note that it says in millimeters. How much more water can the tank hold? And then liters to cubic meters. So in this question, you can see that 1.75 is in meters already. The final answer is in cubic meters. So it makes sense to just convert these to meters. But before that, it talks about how much water the tank can hold. For that, you would just need the internal dimensions, because if you imagine a box and you were trying to fill the box up, you'd only care about how much you can fit on the inside. External dimensions can be as big as they want. It could be a really thick box, but it won't change how much you can fit on the inside once again. That's the same thing with the tank. So if you were to quickly convert everything, so you need to be able to do conversions fast. So millimeters to meters, you would just divide by 1,000. So the 3,000 will become 3 meters, 2,000 millimeters will become 2 meters, and the 2,000 once again become 2. You've already filled a height of 1.75 meters. From the formula, you can see the height is here, and the maximum height is 2 meters. So how much more can the tank hold? You just need to find the difference between the 2 meters and the 1.75, which would be 0.25 meters. That's how much you have left, because the height is the only variable that's changing. Because the height is the only variable that's changing, that's the one that you have to obviously use to work out the answer. So your 2 meters take away 1.75 gets you 0.25 meters. Then times it by your 3 and your 2, obviously, to find the volume, because that's how much water it can hold. So times your 3 times your 2 gets your value of 1.5 cubic meters. And as you can see from here, 1 liter is equal to 0.01 cubic meter. To find out how much 1.5 cubic meters is in liters, you would have to do your 1.5 and divided by your 0.01. Not divided, sorry. Yeah, divided. Sorry, guys. All right. So you would do your 1.5 meters meters cubed divided by your 0.01 to get your value of 1,500, which would be, sorry, D, would be an answer of D. There's also another way to do this method, to do this question. The method's right here. I think that's just a longer method. So what they essentially did is 3 times 2 times 2 gets you your 12, then your 3 times your 2 times 1.75, which would be 10.5, then your 12, take away 10.5, gets you a value of 1.5, and then convert as I did. So like they've done here. That's the method you can do. If you find that easy, you can do it. There's nothing wrong with it. It just takes, I just believe it takes extra time. It has extra steps that you don't need. Now moving on to the, did you understand that, Akshara? All right. Did everyone else understand that as well? Yep. All right. All right. Next question. So looking at this, the government spending on health services and social protection was 120 billion and 190 billion dollars respectively. So that belongs to that. That's what respectively means. So because that came first, that belongs to the first number. That came second. That belongs to the second number, respectively for year X. In the same year, the government spending on debt interest was 33.33% of the spending on health services. Just convert that. That just means it's 1/3 of the health services spending, and the spending on health services, social protection, and debt interests constitute 50% of the total spending by the government. So obviously $120 billion, just ignore the billions and just use 120, 109, or 12, 19, whichever ones you want. What is the government's approximate total spending for year X? So using the values we already have, so to 120 or 190, you get 310. The debt interest was 1/3 of the amount spent on health services, so 1/3 times 120, or 1/3 of 12, whichever one you want, you would get an answer of $40 billion. So 120 at 190 is 310, plus 40 is 350. And that constitutes 50% of the total spending. So what's the total spending by the government? Well, 50% to get to 100%, you just times by 2. So 350 times 2 gives you an answer of $700 billion. As this is right here. The reason why I said, obviously, just instead of using the calculator for this question, because it would just give you that value, it's better to just do that one in your head. It just looks way better. Anyway, moving on to the next question. The snow leopard in country A is 40% of the snow leopard population in country B. The population of snow leopards in country C is 50% of that in country A. If the snow leopard population in country C is 520, what is the snow leopard population in country B? So in questions like this, you're not being given anything apart from one actual integer value, which is for country C. So that's where you start. So country C, and we're trying to find out country B. So what we do first is country C population is 50% of country A, which means country A is double that of country C. So 520 times 2 is 1,040. Now the population in country A is 40% of the population in country B. So you have your 1,040. And as I showed you before, the 1,040 is equal to 0.4. So what do you do to find out how much 1 is? If you want to pop in the chat, guys, if your 1,040 is equal to 0.4, what do you need to do to work out how much 100% is? Oh, all right. Okay, so as I showed previously in the other question, to get from the 0.4 to the 1, the simplest thing you can do is divide by 0.4. So what you would do in this question is just do your 1,040 and divide it by your 0.4. Just with percentages, that same principle applies. Yeah, you're right. You're right, Akshara. Yeah, it would equal 2,600. And that's basically the principle you need to apply to every percentages question in the UCAT. Because they just ask you the same thing over and over, but with different numbers most of the time. So your majority of your marks come from there. Pattern recognition. Okay, now we're moving on to the next type. By the way, did everyone understand that these 3 questions, or do you need me to further explain? Don't be shy, guys. I'll explain them again if you want. No, all right. Oh, the second one, all right. Second one, the government spending, all right. So It talks about the government spending on health services was $120 billion, because that's what respectively means. And social protection was $190 billion for a specific year. In the same year, the government spent on debt interest was one third of the amount they spent on health services. And the spending on these three added together, so health services, add your social protection, add your debt interest, is 50% of the total amount that the government spent in that year. So what you have to do firstly is find out the one value that's missing, which is the debt interest. And it tells you right here that the debt interest is 33.33% of the amount that they spend on health services, which is $120 billion. 33.33% just as a fraction is just one third. So one third of $120 billion is $40 billion, because one third of 12 is for, if yeah, that's just maths. So it's just 40, add 120 is your 160, and then add your 190 is $350 billion. That's how much all three of those sectors cost. And those three added together was 50% of the total spending. So if $350 billion is 50%, then 100% would have to be times, so 50 times 2 gets you to 100. So 350 times 2 would have to be $700 billion. Does that make sense? Yeah, all right. And the other thing I said about here is the reason I said use a fraction over decimals and percentages, because it doesn't give you an accurate value. So it's better off not using your calculator for this question. All right, moving on. So going into diagrams now. Sometimes diagrams questions can be really hard. And other times they can just look hard. So this question here looks hard, but it's not that hard. Okay, so let's start with the top one. So Jamie wants to create a cubical lid for a gift box as shown in the figure. What is the total area of the cardboard pieces required to make the lid? So this is just looking at surface area, and it's giving you the values here. Guys, I want you to actually attempt this question, because I believe everyone can get a, if I'm being honest. This is one of those really more of a problem solving than a maths question, but it's not that much problem solving. It's more like a trick question. I'll go through it in 1 minute. Because if anyone wants to give a guess, it doesn't matter if it's not right. We're here to learn. Any guesses? B. All right. I'll quickly go through it. Okay, so what you'd have to do here is the total area of cardboard pieces required to make the lid. So ignore the rest of the box. Just look at the lid where the dimensions are given. And then start by working out how many faces there are. So there's one face here, there's one face here, there's one face here. There'd be one face at the back that you can't see, and then another face that's unseen on this side. You would do firstly the face you can see 6 times 8, which would give you an answer of 48. Then you would do 1 times 6 to work out these two sides. So 48 plus 6 plus 6 gives you an answer of 60. Then you have these sides here. So this actually caught me out first time I did it. But you'd have to do 8 times 1 and 8 times 1. So it'd be 48 plus your 12 here, which gives you 60, and then plus 8 here and 8 here. And you actually give an answer of 76, which is D. Achara, do you want to, like, why did you think it was B? Just so I can explain if there's any misconceptions. If it was just a guess, that's all right as well. Oh, it's all right. It's better to guess in the UCAT. Don't leave any questions blank, honestly, because you could actually get it right and you would have lost that mark just because you didn't guess. So guess. That's what I did for questions that were unsolvable during my mocks. Okay, now moving. So times 8 times 6 1. Yeah. So it's because if you imagine a cardboard box, it will just have that 8 times 6 once. You're not going to put one there and then one at the bottom. It's just 8 times 6 for the top part, and then obviously the sides to put it on, put it in place. All right. Now this next question, it looks really hard, but it's actually really simple. You're given not coordinates, a compass with your north, east, south, and west. Ignore all this information for now. There's too much information there to even bother. So just look at this first, the question. So the distance between camp 1 and camp 5 when traveling in a clockwise direction is approximately. Now look at over here. So you've got camp 1 here, and then you've got camp 5 here. A clockwise direction moves obviously this way. So you'd be going from camp 1 to 2, 2, 3, 3, 4, 4, 5. And that in total, that's 3 plus 1, which is 4 days. 4 plus 3 is 7 days, and 7 and 2 is 9 days. But it doesn't want to know the days, it wants to know in distance. So there must be some information here that tells us about it. Journeys are measured in 4 days. Journeys are measured in days, and 1 day's journey covers 15 kilometers. You think the answer is C? Let me check. You are right, correct. Well done. Yeah, actually got. So do you? All right. Yep, that's correct. Well done for that. I'll still explain it for the rest of you lot. So obviously 3 plus 1 is 4, 4 plus 3 is 7, and 7 and 2 is 9. Then 1 day is equal to 15 kilometers. So you just do 9 times your 15, gets you 135, which is short spot is. So well done. And then moving on to the next question. So the shortest distance between camp 6 and base camp is approximately, once again, it's in kilometers. So camp 6 is here and base camp is here. There's no distance here, so it would have to be coming all the way around. That's a long distance. This is the shortest possible distance. Because this shape is given to you here, just imagine you're making a triangle, essentially. And for here to here, that's halfway through there, so that would be 1 day. And then from here to here, that's 2/3 of the way through, so that right here would be 2 days. And then if you just use Pythagoras theorem, you do 2 squared and 1 squared gets you 5, and then obviously using the square root button that you have, you would do root 5 and then times it by 15, and it gives you an answer of 33.5. Rounding that is 34 kilometers. I believe there is another method to do that question as well. It's to do with something here. Yeah, all right. So from here to here, I believe. Oh, sorry. Wait, where is it gone? Oh, yeah. All right. So because this distance here is 2 days. Oh, give me a second, guys. Yeah, it's just the Pythagoras theorem, guys. I don't know why I started second guessing. Don't second guess, guys. You might end up getting it wrong. But yeah, I see the answer for that one. Did you understand the explanation, guys? It's kind of a problem-solving question now. All right, you understood it. Okay. The next question. So the weight of essential supplies that must be carried by a single sledge team on a return trip from camp 4 to camp 5 as a percentage of the maximum load is. Now this percentage is once again. One thing to remember is that a return trip means you go from camp 4 to camp 5 and camp 5 back to camp 4. So it's not just 2 days, it's 4 days because you're going there and back. Essential supplies for a 4-day journey are 40 kilograms for the handler and 10 kilograms for each dog. It says right here. Wait, let's read all the information. So essential supplies are transported by sledge. Each sledge team consists of 2 dogs and 1 human dog handler. A sledge can carry a maximum load of 150 kilograms. Essential supplies for a 4-day journey of 40 kilograms for the handler and 10 kilograms for each dog. So 20 kilograms in total, and journeys are measured in days, and 1 day's journey covers 15 kilometers. All right, so from that, the information that we actually need is that there's 2 dogs, 1 human. So 40 kilograms and 20 kilograms is 60 kilograms in total. That's for a 4-day journey. And then the maximum load is 150. So if you find out what percentage 60 is over 150, you just do 6 divided by 15. You would get an answer of 2 out of 5 or 40%. Did that make sense, guys? All right. And then the next one. So a single sledge team set out on a one-way journey from base camp in a clockwise direction following the route on plan. The sledge is packed with 150 kilograms of essential supplies. The last camp it can reach before the supplies are used up is. Okay, so the way to go about this question is, instead of trying to work out how many kilograms per handler or per dog, just do 40 add your 20, you get 60. 60 kilograms is used up by the sledge team over 4 days. So per day, they use up 15 kilograms. If the maximum load is 50 kilograms, 150 divided by 15, you would see that their load only lasts them 10 days. And then look back here, you would get 2 days here to get to camp 1, so it can't be camp 1. Then 5 days to get to camp 2, can't be camp 2. 6 days to get to camp 3, can't be camp 3. 9 days to get to camp 4, so it can't be camp 4. 9 days to get to camp 4. And then it would take 11 days to get to camp 5. The question says the last camp it can reach before the supplies are used up is. Some people put 5 here. The answer is actually 4 because you would run out of supplies halfway through your journey, so you never actually make it to camp 5. That's one thing that you do have to remember with this question, and some people do make a mistake. So the answer would be camp 4 for that question. Does that make sense, guys? And that's essentially diagram questions. They're not really all that hard. With enough practice, it just becomes like repetitive. That's just the thing about the quantitative reasoning section. All right, we're moving on to line graphs. I'll just show you this question. So the average of the net carbon flux for the 7 localities was 6.1 million kilograms per kilometer squared per year. What was the net carbon flux per kilometer squared per year for the 7th locality selected for the study? All right, so as you can see here, there's let's read this information. The net carbon flux population for 6 of the 7 locations, and it's the difference in the amount of carbon released. You don't need to know that information on the top. It's just big words to throw you off. But 6 are already here, and you're looking for the 7th. We're rearranging the mean formula again. You see how it comes up in line graphs, averages as well. So that's what we're doing here. So you know that your mean is 6.1. By the way, if it says average or mean, it's always just use the mean formula. So for 7 localities, it's 6.1. Ignore the million, the kilograms per kilometer squared, because that's just that unit there. So just look at the numbers here. So you do 6.1 times 7. And the reason I say that is because, let's say, for example, you have 10 different values that add up to 50. Your mean would give you let's say your mean is like 5, and then you just times, your mean's 5, and you have 10 values. You times it by 10, you get 50 again. Do you see what I'm trying to say? So you just need times the mean by the number of values to get your total value. That's how mean works. In the UCAT, you get lots of questions like that. So 6.1 times 7 gets you 42.7 million, blah, blah, blah. And then you have 6 values that are given to you. Read them off the actual graph. So over here, you have 12. So take away 12 because that's A gone. Then take away 10 for B. Then take away 6 for C. Take away 5 for D. Take away 4 for E. And then over here, some people might make the mistake of taking away 1 for F. You actually have to add on 1 because F is in minus numbers. So don't make that mistake. And then you get a value of 6.7 million kilograms. And that's what your answer should hopefully be. Yep, 6.7 million kilograms. And the reason why that works is if you were to add the 6.7 to all the values and divide by 7, you would get the mean of 6.1. So you can check that way as well. One simple thing as well you can do in this question, if you don't want to go through all that, is you can actually never mind. I don't want you to get into bad habits. So anyway, moving to the next question. So what is the difference in the net carbon flux per person per year in locality B and locality B and locality. I'm not sure what that question is. Questions cut off, guys. Anyway, in locality B, unless sorry guys, it doesn't really have a question right there, but 2,000 kilograms between B and I think that's supposed to be C. I'm gonna just assume it says C, guys. So to do the, because you still don't know how to do this, so look at both sides. So your population is here and your net carbon flux is there. Per kilogram per year, blah. So look at B right here. You have a value of 1,250 for your population and then 10 million over here. So what you would have to do is your 10 million, obviously. You can make it into a smaller number if you want to. So if you were to get rid of all your zeros, how many zeros are there? So there's 10. And then 6 zeros after that. If you were to get rid of your 6 zeros, just do 10 divided by 1.25 divided by 10 to the power of 6. You get a value of 1,250. You'd get a value of 8,000. That's how much each person produces in that locality. And then if you were to do the same thing for C, which would be 6 million divided by 1,000, you would get a value of 6,000. All right, yeah, you'd get a value of 6,000. Oh, I think it was B and C. So you'd get a value of 8,000 for B and a value of 6,000 for C. And taking them away, you'd get a value of 2,000 as the difference. Guys, if you don't understand that, I'll explain it again. Which is I was a bit thrown off that the question wasn't there. You understand it? All right. Does everyone else understand it? All right. Okay, the net carbon influx per year per person per year due to transportation in locality D is 28% of the net carbon flux per year per person per year. What was the net carbon flux per person per year for factors other than transportation in locality D? All right, so if we were to go onto locality D right here, they produce 5 million and there's 750 people, the population. So what you have to do for this question is 5 million divided by your 750. And you see that you get, because it has a value of 28% is due to your transportation, the remainder would have to be for other factors would have to be 0.72 or 72%. So what we do then is 0.72. So okay, so look at locality D right here. You got 5 million, and then you got 750 people. So you do your 5 million divided by your 750, and they give you a answer of like 6,666.7 or something. And you know that 28% of that is due to transportation. To find out how much is due to other factors instead of transportation, you would have to do 100%, take away 28%, it gives you a value of 72%. They do 72% or 0.72 times your 6,666, and you get a value of 4,800 kilograms if you put that into your calculators. Moving on to the next question. If new technology is building and water heating, if new technology in building and water heating is used, then the new net carbon flux per year for locality D will be 3.2% of the current net carbon flux per year for locality D. If the area of locality D is 1,400 kilometers squared, what will be the amount of net carbon flux per year due to the new technology? So you have the value here is 5 million. It's 3.2% of that. So if you use your multipliers, so 3.2% as a decimal, 0.032. So 0.032 and times that by 5 gives you a value of 0.16, and then times that by, that's, if you look over here, it says per kilometer squared. So you need to times by 1,450 to cover all areas, and you would get a value of 232 million kilograms. Does that section make sense, guys? Line graphs are a bit more complicated, but that's just, I think, more because of you don't understand it. Which question do you understand? The last one, all right. So because they build a new technology, less carbon is emitted. That's what we can assume from the question, because it says that locality D, the amount of new carbon introduced is going to be 3.2% of the current number. And as we established at the beginning, the current number is 5 million per kilometer squared. So what we do is find out what 3.2% of 5 million is. So you do 0.032 times by 5 million, because 3.2% just means 3.2 divided by 100, which is 0.032. Times that by 5, you get 0.16. And because over here, if you read the axis label, it says it would be 0.16 per kilogram per kilometer squared per year. So that's only 1 kilometer squared in locality D would be 0.16, but locality D is actually 1,450 kilometers squared. That's the area of it. So we'd have to do 1,450 times by your 0.16 to get your answer of 232, because the 0.16 was only for 1 kilometer squared. For the whole area, you need times by 1,450, because that information is given in the question. Does that make sense? Okay, got it. All right, no worries. Okay, and that's it for the other types of for all the data presentations. You'll get quite a few questions, a mix of all of them. And now I'm going to go into the other types, just because tax, most people don't know how to do it, so I'm going to show you how to do it. And yeah, it's not that common, to be fair. I didn't get no tax on mine, but we'll do it anyway. So yeah, ignore the information. You can look at this, for example, if you need help for it. So for example, a person with annual taxable income of 60,000 will pay 4,990 plus 25% of the difference. Bill has an annual taxable income of $28,950. To the nearest dollar, the income tax he has to pay is. So the main thing to remember with taxation is, firstly, find which bracket it falls into, and it falls into this second bracket here, 8,950 to 36,250. That's the bracket it falls in. But that's the mistake most people would do, is that they would do 28,950 and times it by the tax rate, which is 0.15. You don't do that. What you actually do is you do 28,950 and you take away 8,950. And the reason I say that is because the 8,950 is covered in the lower bracket, so it falls into that percentage, not this percentage. Does that make sense? So the first $8,950 that Bill earns is taxed at 10%, not 15%. So you have to do the total minus the lower bracket, so 8,950 gives you a value of 20,000. Then you times that 20,000 by the tax rate, which is 15% for his bracket. So times 0.15, 15%, whichever one you prefer. And you get an answer of $3,000. Now, some people might just get confused here. There's no $3,000. What you need to remember is that his first 8,950 was taxed at 10%. So the total tax you can pay for the top of this taxable income bracket is 895. So 3,000 plus 895 gets you a value of $3,895. Does that make sense? So just adding the taxes together. So the answer for that would be, well, it should be B, but I think the green has moved off it. So you took away the last number of the first bracket. Yeah, because that's the total. So because he's higher than that tax bracket, he's paying the maximum for that, which is 895 right here. That makes sense? Yeah, okay. Just need to quickly check some minus 890 times minus 0.1. Yeah, is 38. Is 3895, guys. I don't know. I think when I changed the sizes, it went on the wrong screen. But anyway, so Corey has an annual taxable income equivalent to $2,500 per month. She wants to save enough money each month to pay her tax for the year. The minimum amount to the nearest dollar that Corey has to save each month is. So because she has an annual taxable income equivalent to $1,500 per month, so you have to do 2,500 and times it by 12 just to find out how much she makes in a year. That's just her monthly salary, guys. And by times it by 12, you get 30,000 as your answer, which means that she falls into this bracket again. Now, as we did with the previous question, 30,000, take away your 8950, gets you an answer 21,050. Then times that by 0.15, add your 895, and you get a value of 4,052.5. It's just the same as the first question. The only difference now is that you have to divide your answer by 12. And you should get an answer of $337.7. The reason divide by 12 is because she wants to pay monthly. I mean, she wants to save monthly to pay for the whole year. And obviously, when you round it, you get an answer of 338. Once again, I think because I rearranged the sizes, but the answer is C for this, the answer is B for that. Moving on to the next question. So Omar has a taxable income of $36,250 per year. What percentage correct to one decimal place of his taxable income does Omar pay in tax? So $36,250. Now, over here, there's something that many people do. This is actually a really simple question. There's something that many people do, and it's really just a common mistake. So don't really fall for it. Don't fall for it. But they do 36250, and then they'll see that okay, 36250 times 0.15 gives you the 4990 because obviously it's at the top of that tax bracket, and then they'll make the mistake of adding the 895 and then using that as a percentage. Don't do that. The reason why people get confused with that is because obviously they think it's the lower tax bracket. You must add that as well. That's only when you're within the tax bracket. When you're at the top of the tax bracket, you don't need to add that. And the reason for that is because the value is given on the side, the total tax paid. The total tax paid includes the ones of the brackets below. So you don't need to worry about that. So all you need to do is your 4990 divided by your 36,250, and then you just times it by 100, and you get a value of 13.76% or 13.8% right here. Does that make sense, guys? Do you understand why? It's just because of the labeling total tax paid. So it includes that bottom already, in the bottom bracket. All right, so moving on. The values at the bottom endpoints and top endpoints of each income tax bracket are going to be increased by 10%. What will be the change in income to the nearest dollar after tax has been deducted of a person with a taxable income of 36,250? Okay. So the thing to remember with this section is that the bottom one of this is going to change, and the top one of this is also going to change because we've established which bracket it's in. It's the second one. So if you do your 8950, you times it by you times it by 1.1, you'll get an answer of 9,845. And 9,845 is the amount you pay in that bracket as well, by the way, guys. So 9,845 is the new top bracket for the first category. So that's charged at a rate of 10%. So instead of 895 being added to your answer, now you're going to have to add 984.5 because that's 10%. And you're probably wondering why you're not using the 4990. It's because the top half of this 36,250 is going to change as well. So you do 36,250 times it by 1.1, you get 39,875 minus your 9,845. You get 30,030. And then add your 984.5, you'll get 31,014.5. I don't think that's right, actually. Give me a second, guys. 8,950 times it by 1.1, you get 9,845. Oh, yeah. Then you do 36,250 minus 9,845. Sorry, I took away the wrong thing. And you get a value of 2,000, a value of 26,405. Then you times that by 0.15, gets you a value of 3960.75, and add your 984.5, gives you a value of 4,945.25. Now, what would be the change in income after the tax has been deducted? Well, as you can see, you don't need to calculate all these other stuff. You can just compare the 4,990 to your $4,945. And you can see that the difference is just $45. So it's just a $45 increase. Does that make sense, guys? All right. Oh, I forgot about this question. Once again, this is another percentage change question. I just wanted to show you how you can use the percentage decrease, percentage increase thing, if you want to use that formula there. So what is the percentage decrease in the number of steps Omar walked from week 1 to week 2? It's a really simple question. You don't even need to look at all the other people. That information is useless, irrelevant. It's just there to overstimulate you. But yeah, from week 1 to week 2, 46,800 was week 2, 90,000 was week 1. So 46,800 divided by 90,000 using the formula I've got there gives you an answer of 0.52. 0.52, and then to get to the 1, you see that the difference is 0.48, so the answer is actually 48%. So the answer for that's 48%. Does that make sense? And I'm going to quickly go over one more thing as well, ratios. Just because I think ratios are really simple, but there weren't really many questions. So what is the ratio of the number of customers who rated brand A product to the number who rated brand B product? So obviously finding the total, so it's addition as well as ratios. So 4 at 5 is 9, plus 8 is 17, plus 12 is 29, plus 11 is 40. And then on this side you have 28 plus your 28 is 56. And you have your 40 to 56 is your brand A to brand B ratio. Now, what you can do is obviously do 40 to 56, see which one matches, or you can just do 40 divided by 56. You'll get 5/7. Which other one would you get 5/7 with? You would get it with C. That works for any, like I've given a really simple example, so it doesn't look that mega, but you have some other questions that have really complex numbers, like 113 and 72, and then they'll just have like loads of different numbers. If you just do the 72 divided by the 113, and it gives you a value, and then if you get a corresponding value that's exactly the same in your answers, that's the correct answer, and that's your simplest ratio. So yeah, that's the ratios questions done. And then I'll quickly go over the time-saving tips. Learn these conversions, guys. So your weighted mean is your value times your weight 1 plus your value times your weight 2 plus your value to the power of x plus times your weight to the power of x, and then divided by total values. And that's how you do weighted mean. I believe you do a GCSE statistics if you chose it. Then ratios, as I just showed you, divide the first number by the second and do the same with each answer till one matches the decimal you get. That's just a quick way to do ratios. Don't deal with big numbers, remove zeros if you have to, but it has to be for all values, as I showed you before. When answer options are very different from each other, you can use estimation. If they're very close, like they're just 1 or 2 values apart or 0.1 apart, don't estimate, work out exact values. Learn your multiply for percentage changes. So obviously, well, you don't really need to learn multipliers, but you have the 1.6, it would be a 60% increase, so 0.4 would be a 60% decrease, that type of stuff. A very important one as well is if something increases by 100%, that it has doubled, but the multiplier would be 2. If same thing for tripling, it would be 200% and the multiplier would be 3. Just something to remember. Then learn your fraction decimal conversions, just the simple ones like 1/5, 1/4, 1/8, 1/6, 1/3, 1/10. Yeah, that's 1/3. That's about it. Not that many, but as you practice, it'll just come to you anyway. For mean on some questions, you can sometimes find the right answer by adding the final digits together. That's very true. So if you have lots of values, so for example, if you have lots of values, you can just add up the final digit and divide, and sometimes in the answer there'll be the correct answer. So for example, if you're adding up something that ends in 4, 4 and then 3, and then like 1 or something, and you'll get 12, and then if 12 divided by 4, you get 3. So if any of the answers end in 3, you'll know that's the right answer. So that's something that just to save time. If you're running out of time, that's more like a if you're running out of time type of thing. Don't do it if you can work it out normally. This one, which I've been doing all day, I mean, all throughout the session, read the question for the information, because sometimes the information is just useless. It's just there to complete the table, but it'll do you no good. So there's no point dwelling over that. Only look at what you need. And that's what the top students do. They look at the information they need, not the information that's there. Yeah, let me quickly go through the common mistakes and top tips before I go over the MedReadyGo website. So flagging a skip in is the easy questions are usually located after the harder ones. That's the reason that there's because most people spend lots of time on the hard questions, so they won't get to the easy questions. It's I think it's set like that for a reason. Avoid spending more time than allocated per question, because all questions in QR, they're just worth 1 mark. So there's no point dwelling over a really hard question because it's still worth the same amount of marks as another question. I know some people don't like leaving questions blank, but it's not a regular test. It doesn't really matter. Sometimes questions in the UCAT don't even contribute to the final score if they're trial questions. Use a mixture of techniques. That's really important. One technique might not work for you, so use lots of different ones. Train your mental maths. Don't rely on your calculator for simple calculations that you can just do in your head. It just wastes a lot of time having to type it out. Opening your calculator, because sometimes it's a bit slow depending on the computer you have in the actual UCAT. Take a few seconds to compose if you are overwhelmed. Taking those 5 extra seconds to just compose and meaning you can answer like 5 extra questions is way better than panicking and not taking a break and you end up answering no questions at all because you freaked out. Learn and write out different formula at the start of the question. That's what I did. So when you know the QR section is coming, you can write out your formula: speed equals distance of time, d equals m over v. Write as a triangle if you want it. It just makes it way easier to rearrange it. Like a half base times height is equal to area of a triangle. I know it's not decision making, but I'll give you a decision making tip as well. Just draw blank Venn diagrams before you start the section, just so you can write the numbers in and you don't have to waste time drawing a Venn diagram. Then this one, attempting time practice ASAP. It helps get used to timing. You've all seen today that the questions are not that difficult. The questions are repetitive. So even if you don't know these questions that I showed you today, chances are you'll see them again in the future with different numbers and you know how to work them out. It's just the same principles. The timing is the hard part. It's just rapid fire. But once you get the timing on your belt, you can easily score. You should be scoring 800 plus in the quantitative reasoning section. Once again, practice over and over. The questions get repetitive. Practice using the number pad and keyboard shortcuts. Make sure your number lock is on. Keyboard shortcuts, they're your best friend in the UCAT. Using those and learning how to do the subconsciously is the best thing you can do to save time, save those extra few seconds. Because imagine saving 1 second per question. You'll have an extra 30 seconds to check over your work. And don't overthink. Most, if not all, the questions in this section are GCSE standards. So stop trying to. It's not, most of the time it's not a trick question. It's something really simple, and sometimes people are thrown off by it because it's like a medical and dental school entrance exam, and it shouldn't have such easy questions, but it does for some reason. So don't get thrown off by that, and yeah, just be confident in your answers. And I'll just quickly show you the MedReadyGo UCAT platform. It will take quite a long time. Yeah. All right. So this is the MedReadyGo UCAT website. This is the different types of bar charts we have. We're going to be opening mocks. There's going to be mock sets for students that upgrade to Pro and have a subscription. I believe this stuff over here you can use though. You have bar charts, pie charts, line graphs, multiple diagrams, tables, no diagrams. If you don't want to write in the chat which question type you'd want to go now, like you want to answer, and I'll generate a few questions and show you them. So do you want bar charts, pie charts, line graphs? Just in the chat. whichever ones you want me to generate right now. You want line graphs, all right. 2 passages. I'm gonna put it untimed, but it should. Yeah, once you get used to it, all right. So this is what it actually looks like. If you can see my screen, so you'll have your calculator here. That's what your calculator looks like. Use your number pad to use it. And there's all your different functions. Flagging for review, that's something, when I said flag and skip, it means you flag for review, you come back at the end and it'll show that it's flagged. But if you want to try this question, guys, I will go through it very quickly. So the line graph below shows the total monthly energy consumption recorded for a household across 2 consecutive years. Energy consumption measured in kilowatts per hour. Each data point represents the total energy used during that month. By what percentage did the household energy consumption decrease from January year 1 to January year 2? So you have the key right here. That's year 1, that's year 2. Looking at January. January is right here. So January year 1 is at 425-ish. And over here for year 2 is at 390-ish. You've got D down as your answer. I'll put it down. And I'll go next. I'm trusting you on this. Once again, what is the mean monthly energy consumption for year 2 to 1 decimal place? So you just add up all these values and you divide by 12. So 390 plus 350 plus 275 plus 210 plus 160 plus 140, I believe, plus 140 plus 140 plus 150 plus 225. So let's count. 225 plus 300 plus 375. That will divide by 12, and I got an answer of 238. Well, I don't think that's right. But yeah. What is the total reduction in annual energy consumption from year 1 and year 2? So you just add up all these values and you would find the difference. Yeah, this is what it really looks like. I'm just going to guess this because I can't be zoom in enough to see it. The diagrams, obviously on our website and in the real UCAT, they are bigger. You can't zoom in, but I can't right now because I've got the meeting on in the background. Okay, in which month was the percentage reduction in energy consumption from year 1 to year 2 the greatest? So what you have to do for this question is put the values over each other and see which one's the greatest reduction. I'm just going to go purely off by my eye and see which one I think it is. And I do believe it would be November or December. Nope, that's not even an option. Which ones do you think it is? I think it might actually be there. Yeah, I'm just going to put October. No, I'll just put May. Actually, April. Yeah, April has quite a big gap. And then this is also another question. We're doing sets of 2. I'm just going to submit just to show. Wait, actually, I'm going to actually flag for review just to show you what the flagging looks like. Oh, we got 1 out of 8. Let's see. So the answer that you gave for question 1 was right, and then every answer after was wrong. But anyway, that's what the MedReadyGo website looks like. The QR section specifically. We obviously have the verbal reasoning, decision making, situational judgment. We have the dashboard as well with all the activities so you can track your progress. And obviously streak as well, average scores, your analytics, just to see how you're doing. So obviously I did verbal reasoning and I skipped out questions as well. But yeah, that's basically all that we have for the MedReadyGo. That's all we have for the MedReadyGo website. So we have all 4 sections. We have questions as well. Obviously, alongside the workshops, it should prepare you for your UCAT. And then moving on to the next section, we have the Q&A and feedback feedback time. If you do have any questions right now, any feedback you want to give, any questions, any section, then feel free to ask. Next session is going to be in decision making. If you are interested in that, and if you have any questions, you can leave them in chat. If not, have a good rest of your day. No worries, you're welcome.